Hello, everyone. Thanks for tuning. I'm Srini. This talk is on improving developers' life with distributed SQL. Like last year's summit, this year is no different. It's even bigger and more informative. This year has lined up a lot of interesting talks on use cases, success stories, and other technical sessions. If you haven't subscribed to those talks yet, I would highly recommend to do so. I had the chance to have a sneak peek at some of those talks. It's really amazing to understand how customers and partners are building interesting solutions with Yugabyte. All right, let's get started. The way how I'm going to do this session is I'll run through a practical demonstration of building a cloud native application from scratch. Before we do so, let's try to understand the ecosystem itself. As you know, modern day application architecture is complex. I'm not saying that we did not have this challenge in the past. In the past, the choices were limited, the standards were confined, so we had to pick and choose one of those and then move on. But that's not the case today. Even if I look at the client-side framework options alone, the choices are plenty. There are so many framework options out there. Though everything is built on JavaScript, but each one does its own thing. When Angular came in, everyone thought that the next gen front end framework applications are going to get standardized on Angular. And then React came in, people started talking about React, and then they moved on to React. And today everyone is talking about Vue. Who knows what comes tomorrow? I'm not saying that Angular is not relevant today. Every framework has its own place today. Again, it depends on the use case and the application that we are trying to build. But more from a developer standpoint, as developers, we need to keep up with the pace at which the open source ecosystem is evolving. It is evolving at a very rapid pace. If we move on to the server side options, it is no different either. If I have to narrow down to one of the standard languages like Java, we have Spring Framework, Quarkus, Micronaut, and the list doesn't just stop there. The application will still need to be integrated with other libraries for addressing cross-cutting concerns like client-side load balancing, service discovery, authentication, authorization, retry, circuit breaker, and so on and so forth. And if you look at the deployment options, those options are not limited either. In the past, especially in the enterprise Java, we used to have 2 or 3 options like WebLogic, WebSphere, and JBoss. But if you look at Kubernetes alone today, there are a lot of companies provide different bundle and package version of Kubernetes. Again, even within Kubernetes alone, the choices are plenty. And then we have Heroku-like platform as a service, Cloud Foundry, OpenShift, and native cloud providers offer tons of different mechanisms to deploy your applications, function as a service, and the list keeps on growing. And CAC is no different, right? Though all these things do one and the same thing, but each does it in its own way. As developers, if you move from one tool to the other, we have to go through the challenge of doing some unlearning and relearning as we move on with each of these different tools. And if you spend some time to understand how architecture has evolved over these years, this used to be the gold standard. A lot of applications were built based off this architecture. This has served us well for a reasonable period of time. And this architecture is relevant even today. It does exist. But at the same time, we had to move on. This architecture broke for some of the requirements. Certain requirements don't inherently fit into this architecture. So we had to look at other alternatives. And then microservices came where a single bounded monolithic-based application is broken down into a bunch of services based on the domain model so that each service can be built, deployed, and operated on its own. If you want to compare and contrast with a sample application in terms of how architecture has evolved from monolithic to a microservices, this is a sample e-commerce retail application where all the different components were part of the same application itself, where we are happy with a single node system. But if we look at the characteristics of current days microservices, each service demands its own requirements, right? The characteristics are different. No two services would fit into the same bucket per se. So end of the day, we have to categorize these services into n number of different buckets. Certain services would demand relational capabilities. Certain services would demand three nines or 5 nines. certain services would demand horizontal scalability. If you look at the evolution as such, thanks to the advent of the cloud, obviously, the infrastructure is pretty much scalable and nimble today, and that paved way to the application architecture. In both the cases, the odd man out is the database, right? Data layer, at least. So inherently, we had to move on. We had to innovate and architecture the data layer as well. So the existing data model is not serving the purpose of modern day architecture. So we had to look at other alternatives, and then we moved on from a single node RDBMS system to a sharded RDBMS system, and that also had its own limitations. So we had to look at other alternatives. NoSQLs came in, different flavors of NoSQL databases address some of the shortcomings of RDBMS systems, but at the same time, each solution has its own set of pros and cons. In order to gain something, we need to give up on something. But what we need from a data services, we want the database system to be architecturally resilient, horizontally scalable, ACID properties to be supported, and SQL and RDBMS are the unique value propositions of the database system. A lot of tools, and it's more like bread and butter in terms of how we have built applications over these years using these features. And if the user base is globally distributed, and we want the database system to support geo-distributed architectures as well. So that's where YugabyteDB comes. YugabyteDB brings the best of all worlds. YugabyteDB is a cloud-native open source Postgres and Cassandra compatible, API compatible database, which is horizontally scalable, resilient, and at the same time, it supports geo-distributed based deployments as well. All right. So let's look at what we wanted to build what we wanted to do at first place. So we wanted to build a cloud native application stack from scratch, right? Let's see how we are going to do it in the next 20 minutes or so. And while doing so, I'll try to cover the path to production more from an inner loop standpoint and a high level: code, build, deploy, debug, and test, right? And what we are going to do now is we are going to build this cloud native application. This is the sample retail application that we looked at in the earlier slide. So this comprises of a bunch of backend microservices like product category store, invoice, notification, and then we have a registry service. This is, I mean, as you know, in the world of microservices, the services need to discover each other. So a registry service comes handy, where every service register its whereabouts with the registry service, so that when service wants to communicate with other services in the overall scheme of things, it should be able to do so with the information that is provided by the registry service. Again, if you want to deploy this to a runtime like Kubernetes, you don't need a registry service. Some of the runtimes offer service discovery natively out of the box. But if you want to build a cloud native stack that is platform agnostic, then it makes sense to bundle registry service as part of the application itself. And then we have a gateway service, which is again built based on Spring Cloud Gateway. It's more of a perimeter service through which we interact with the application itself. And through the gateway service, we would orchestrate rest of the other downstream services. The entire stack, we are going to deploy it on Kubernetes. So in this case, I've already provisioned a GKE cluster. Let's see how we can quickly build this application and then deploy it to Kubernetes. All right. The way how we are going to build this application is we are going to use a scaffolding accelerator called JHipster. Again, JHipster is an open source project. It is a rapid application development platform to quickly generate, develop, and deploy modern-day web applications. It supports a ton of front-end and back-end services, the client-side framework options and server-side framework options, and rest of the other deployment CI/CD options that we looked at in the earlier slides. Those things are natively supported by JHipster. Again, the good thing about JHipster is an open source project with a vibrant community. And the JHipster project is designed based on this principle of open for extensions, right? Today, the open source project supports a ton of databases like Postgres and MySQL. What we have done is we have extended the capability of JHipster with our own blueprint. So the blueprint name is JHipster YugabyteDB blueprint. Through this blueprint, we have added YugabyteDB support to the bits code manifest that JHipster generates. It is already available as an NPM module. So if you want to try out JHipster YugabyteDB, all you need to do is npm install generated JHipster YugabyteDB. That would help you to get started immediately. All right, let's go and build the application. Okay, In the interest of time, what I've done is I've already deployed the JSTOR blueprint in my local mission. I'm going to use that YugabyteDB blueprint to generate the code manifest. So the idea here is we are going to go over two different flows. Obviously, we want to build a cloud native stack, which comprises of multiple services. That is the ultimate goal. But before doing so, we are going to build a standalone microservice. The reason why we are going to build the standalone microservices, this is to understand how YugabyteDB blueprint works, how the various aspects of a cloud native service is built using this blueprint library. So that's the reason we are going to build a standalone service first. Okay, to get started, so we have to start with YBDB or YugabyteDB. That would start the generator in your local machine. So it is going to ask a bunch of questions, basically a prompt-driven workflow where you are expected to answer those questions. So this is basically letting the generator know that what is the nature of application that we are trying to build. It is not just the application alone. Sometimes you have to build your services with all those cross-cutting concerns baked into it, right? A service would require authentication, authorization. You might need a persistent store to keep the state of the service. You might need a in-memory caching, or your service may need to be integrated with an external search solution like Elastic. And sometimes you build a solution where you need to exchange messages through PubSub mechanism through a messaging broker like Kafka. And the list goes on, right? Again, it depends on what you want to build. So the idea here is to let the framework know what we are trying to build. So let's go through this first. What I'm going to do is I'm just going to go with defaults for most of the prompts. But again, depending on your requirement, you'll be able to pick and choose different options. So in this case, I'm going to build a microservice. I'm going to go with gateway. Does it require micro frontends? It's not required in my case, but if you need micro frontends, then you can choose that option as well. What should be the base name of your application? I'm good with the default again, and good with the default for the port numbers. The package name is the default. And does this application require a registry? Again, if you want this application to be platform agnostic, then you can go with either Ubeca or Console. Both the registry services are supported. In this case, I'm going to go with no discovery service. And when it comes to authentication, I'm going to go with JOT-based authentication. And this is where the YugabyteDB integration comes in. So we have extended the capability of JSTOR to support both the APIs of Yugabyte database. So it supports Postgres API as well as the Cassandra API. So in this case, I'm going to go with Postgres. And does it require an in-memory cache? I'm going to go with no cache. And what should be the build tool? Again, the choice is yours. You can go with Maven or Gradle. In this case, I'm going to go with Gradle. And I'm going to skip rest of the other options. Those options are not relevant yet. But if you want to integrate it with Elastic and Kafka, then you can choose those options. So as I said before, it supports a ton of client-side frameworks as well. Angular, React, and Vue are supported. I'm going to go with Angular in this case. And I'm going to say S for UI. This allows us to understand what this application comprises of so that we can log into the application to see what this application is built of. And then this is more on the aesthetics part of the application itself. I'm going to go with the default theme and internationalization support. For the rest of the other things, I'm going to go with the default options. Once this is done, what this generator does is based on the answers for these different prompts, it is going to generate the code bits. It is not just the base template alone, though it generates the actual code base itself. And at the same time, these bits are integrated with all the other ancillary services that we chose, right? We chose JOT as the authentication mechanism. So that means that this service should have the necessary bits to facilitate JOT-based authentication. We chose YugabyteDB's Postgres API as the persistent store. So that means that this service should be able to interact with the downstream stateful service. And in a similar way, and I chosen other options, then the relevant bits need to be part of the code base itself. So that's what it does. It is going to take a couple of minutes. As I said before, I've already generated this application and deployed this application on a targeted runtime like Kubernetes. I'll go through that as we move on. So for the time being, I'm going to stop this generation, but I wanted to give that perspective to you. It is going to generate the entire code bit, entire code part of the application itself. So once this is done, What we can do is we can do one more additional step on top of this. That step is adding the domain model support to the application itself. Let's say that I want this application to be packed with a ton of domain models. Then again, you can generate it using this same blueprint itself. For example, in this case, I want to generate an entity called to-do. Let's say I'm building a to-do microservice. Then you can define that entity name. So the entity name is to-do. Again, do you want to generate it from an existing microservice, or you want this for the service that you are trying to generate? So I'm going to say that no. So this is for the actual service itself. Do you want to add a field to your entity? Yes. What should be the name of the field? Task is the name of the field. And what is the data type? So it's a string. I'm going to go with string. And do you want to add any validations? I'm going to go with the default. No. And do you want to add one more field to the entity model? Yes, status. And do you want to add relationship? No. The answer is no. And this is like, do you want to use separate services class for your business logic? Again, it needs to generate the necessary bits for your application to interface with the data layer itself. Whether you want to interact with the data layer directly from the REST layer, REST controller layer itself, or you want to segregate your REST controller layer, service layer, and data layer. Again, the option is yours. So in this case, I'm going to go with the default option. Is this entity read only? No, I want to do read and write. And then you can activate pagination and sort related features. Again, this is a Spring-based application. This generator is going to generate Spring-based application and it uses JPA. So those are some of the aspects of the JPA domain model itself. Framework specific features itself. I'm going to go with the default option. So once this is done, is again going to update the existing code bits with the domain model, whatever we have generated now. In a similar way, you can bundle other domain models as well. And the last part is how we are going to deploy this application. In this case, we are going to deploy it to Kubernetes, right? So that means we have to generate all the runtime artifacts for our application. The way to do that is YugabyteDB and then specify the runtime name itself. In this case, it's going to be Kubernetes. So if I do YugabyteDB Kubernetes, again, it is going to go through the same prompts. What are you trying to build? It's a microservices-based application where this application is located. So I just have to go and select the path. So in this case, this is the path where the service is located. Let's say if I select the application, and you want to set up monitoring for your application. As this is a Spring Boot-based application, it comes with micrometer pre-built into it. So that means that using micrometer library, we can emit metrics from this application. So let's say if you want to consume that metrics in an external monitoring system like Prometheus, then you can choose this option. So this allows an external monitoring system like Prometheus to scrape application-specific metrics so that it is readily available for your consumption. I'm going to go with no. What should be the Kubernetes namespace? Again, these prompts are important because that's the runtime related information that we have to feed into the generator. So based on this information, the generator is going to generate runtime specific manifests or rather artifacts that we are going to deploy to the Kubernetes runtime. So I'm going to go with the defaults again, but if you want to have a custom Kubernetes namespace, you can specify your own option here. And what should be the Docker repository name? If it's going to be public Docker Hub, you can leave it as such. But if you have your own registry, then you can specify that registry information here. And what command should be used to push it to Docker. So if it's a private registry, if you want to use a different command, you can specify the command here. And you want to use Istio, again, it's a service that's familiar in the container Kubernetes ecosystem, Kubernetes space. I'm going to skip this for the time being. And you want to have an external load balancer to your application. Again, if you want to create an external load balancer, then you go with this option. And this is where the persistent store related information comes in. So in this case, when we generated the service, we chose YugabyteDB's Postgres API. As you know, since Yugabyte being a distributed database, more from a production standpoint, we need to deploy multiple instances of the persistent store or rather the stateful service itself. So in this case, since it's going to be a dev deployment, I'm going to go with one. But if it is going to be a production deployment, you have to go with at least 3. And depending on your deployment topology and the other factors, you can either choose 3 or 5 or 7, and based on the resiliency requirements that you need. I'm going to go with 1. And what should be the blueprint itself? In this case, since we are deploying it on Kubernetes, what should be the pod specification. If it is going to be on virtual machine, then this is the virtual machine specification. So I'm going to go with the default again, and then it generates the runtime specific artifacts here. So if you look at here, these are all the Kubernetes manifest file that the generator automatically generates for us. So all we need to do now is we've already generated the application bits for the service. We attach domain model to the service, and also we have generated the runtime specific, platform specific manifest as well. Now, the next step that is pending is to deploy this application to Kubernetes, right? The way how we do is we use a tool called Scaffold. Scaffold is again a command line tool that is pretty much known in the container in Kubernetes space. It is a command line tool for handling workflows in terms of building your application, creating the Docker image, packaging it, and then pushing it to a registry, and then finally deploying it to Kubernetes. The entire workflow is handled by Scaffold. So it's more of a continuous development tool that is pretty much known in the container in Kubernetes space. So what Scaffold run does in this case is it looks at the generated manifest, generated code bits, and based on that, it creates a build manifest for your application. Based on the build manifest, it creates the image for your application. In this case, this being a Spring Boot application, it creates the Uber jar. And since the targeted runtime is going to be Kubernetes, we have to create a container image. So it creates the container image, and then this image is pushed to a registry. So if it is a private registry, in this case, it is a private registry though. So the image gets pushed to a private registry, and then based on the runtime artifacts, the application gets deployed. So all these things are executed with a single command using Scaffold CLI. So Scaffold run does all these things out of the box. So in this case, deploying a standalone microservice took us close to 1 minute and 15 seconds. All right, so let's move on to the second workflow, which is building the sample e-commerce retail application. So we looked at one way of generating application-specific bits, which is like going through the prompts and then generate application-specific information. So in the case of a complex application which comprises of multiple services, we can go through the same prompts again and again for each and every service, but it's kind of time-consuming, isn't it? The other alternative mechanism is JSS supports something called JDL. So JDL is more of JSS domain language. So if I look at the JDL file itself, the entire application config is defined in this domain language file. So in this case, we want to build three microservices, right? Store, invoice, and notification. And what are the other services? What's the characteristic of this service itself, and what are the other services that this service depends on? So it requires, the store is going to be the gateway service. That means that this is going to get built based on Spring Cloud Gateway, and this is the package name. This requires job-based authentication, and the production data type in this case is YugabyteDB's PostgreSQL API, and this does not require any cache provider. So whatever the information that we provided to the prompt-based mechanism, all this information, we are providing it in the same file itself. And if we move on to the rest of the other file, this is where we are defining the domain model itself, right? We need product category, order status. What is the relationship between all these different domain models? Whether it is 1:1 or 1:many or many, and so on and so forth. And finally, you can define and how you want the domain-specific CRUD options, CRUD endpoints to be integrated with our data layer. Whether you want the data layer, REST controller layer to talk to the data layer directly, or it needs to be segregated using a service layer. Does it require pagination, sort support, and so on and so forth. And finally, based on this information, we can use another alternative mechanism called YugabyteDB, JDL. And if I specify the name of ms.jdl file, this is going to generate all the service-specific application bits for us. It goes through the similar flow like the prompt-based workflow. In this case, we are defining all the service-specific information in the manifest file. And based on the manifest file, YugabyteDB JDL will import the service-specific bits. Again, I've already generated the bits, and then I've deployed the entire microservice, the e-commerce sample service already. So if you look at the workflow here, it is no different from the previous workflow. Again, we have to do scaffold run. So in this case, it has to build three different services: invoice, notification, and store. Again, it has built all those three different services. The Uber jar is created, and based after that, it has created container images for all three services. It has been pushed to the private registry, and then based on the runtime manifest, it has deployed all three services to Kubernetes. So if I go and query the Kubernetes cluster, these are all the different services that are running there. So invoice registry, we chose external service registry. So the Eureka-based registry is deployed. Notification service stored. And then this is more of a production-like deployment, right? So that's the reason for YugabyteDB, we went with the replication factor of 3. So that's why we see 3 instances of T-server, tablet server service there. All right, let's look at the application. Let's spend a few more minutes to look at the application itself. For example, if I want to have a sneak peek at the registry service itself, I haven't created any external endpoint per se, but if you want to create any external endpoint, then in the JDL manifest file, we can specify load balancer as the external endpoint. So in this case, I'm going to do a port forward from my local machine. All right, so if you go back to the browser, the service port is 8080. All right. The registry service is up and running. The default username and password is admin. So if I infer the registry service, I can get to see all the other services, invoice, notification, store, all these services are registered already. The status is up and running. If I go back, if I go to the Eureka instances, if you're running multiple instances of it, then you'll see the instance count as well. In this case, I'm running 2 instances of registry and 1 instance of rest of the other services. And it also provides, if you want to bundle some config information, the registry service is integrated with Spring Cloud config as well. So application specific config, you want to externalize it, and you can bundle it. You can keep it as part of the registry service itself. All right, let's look at the gateway service. So that's the perimeter service through which we are going to interface with the rest of the other services in this application, right? If we do a port forward to the gateway service, let's log into the service. Default username and password is admin. All right, so we are in now. So if I click the entities menu, and these are the different services these are the different downstream services. So the gateway acts as the interfacing point, right? The client application would connect to the downstream services through this gateway. The mapping information is defined in gateway. So if you go back to administration gateway, then you can find that mapping information here. So the URL is of this path pattern, then it needs to be routed to so-and-so downstream service. So that's what gateway does. And again, these are all the different service-specific information. So in this case, when I click the invoice menu, the gateway is going to talk to the invoice service to render this information. So in the similar way, we can interface with the rest of the other services as well. So in this case, what we have done is we did not even do a single line of coding. So we went through the YugabyteDB blueprint, JBoss's extended blueprint, to generate all this application bits through a series of prompts. So we have defined the nature of the application, and rest of the things were automatically generated by the blueprint itself. All right, that's pretty much what I wanted to show it to you. And if you want to try out YugabyteDB blueprint, you can try that out. And as I said before, it's already available as an NPM module. The source code is listed at the bottom of the slide deck. Give it a try and do let us know your feedback. Once again, thank you very much for tuning in. Have a nice day.